So now let's create a collision off of these pieces right here. I brought in the fracture, and so that fracture is, again, all the way down here where we combine all the pieces, fractures out. We have that. I get rid of everything, uncheck these boxes, remove attributes, remove groups. We calculate velocity, and then I'm turning this into a collision VDB with point velocity set to collision vel. So from here, I want to optimize this by basically masking out via the camera where these voxels are able to go. I have an object merge here with the camera view as an SDF, as well as a fog VDB right here. And we'll need to use both because if we middle mouse, you'll see that we have a float field right here. That's the collision field. In other words, our SDF, and our collision vel, which is a fog volume, as a vector 3. So it's holding vector data in those voxels, and it's considered to be a fog volume. So that's why I have SDF and fog. Let's go ahead and just delete the fields that we don't want. So starting with our VDB, in other words, our collision field, let's say get rid of collision vel, and we can use a VDB SDF intersect. So that VDB combine right here will take our mask on B, and we'll take our original collision velocity and give us the intersection of the two. So that gets us from about 2.7 million down to 1 million. Now, for the velocity volumes, VDB combine, let's do the same exact thing, except this time we'll say get rid of colliz right there. And when we combine this, we're going to have an issue at first. So let's say that we try to multiply these two together. We have velocity, which is right there. That's, again, vector 3. We have a float fog volume called cam mask. And right now it says it can combine these two types of volumes together. So what we can do to fix this is turn our camera mask right here into a vector 3 based volume. So let's go ahead and use a VDB convert. Again, we're trying to match this type of VDB with this type of VDB. So let's convert this to a different VDB type, vector floats. So now that's vector 3, and this is vector 3. And when we go to combine, this now works. But the VDBs are all the way out to where the camera begins. And if we middle mouse this, we have 6 million voxels compared to about 2 million voxels. So we actually went up in size by trying to multiply these guys together. So instead, the operation that we're looking for here is going to be activity intersection. Basically, what activity intersection does, if we look at the help docs, is that it says each voxel's active state is set to whether it is active in both A and B. So in other words, we have to have an active voxel over here, and we have to have an active voxel over here in order for any of these VDBs to count. After doing that, we're now down to less than 1 million voxels, whereas before we were at 2.7. And it's really important that we get rid of all these extra voxels because at every single time step of the DOP simulation, it's going to have to read in these voxel values. And if it's reading all that data at every single step, it's going to bog down our simulation quite a bit. So it's really good that we took this step. We merged them back together like so, and we cache that out. So now back here in the DOP nets, we have our volume source, source collision, and just like you saw before, we have the collision field and the collision velocity sourced in. I like scaling this up a lot more just to try to get that faster motion from the pieces. So I have a scale of 10 right there to really exaggerate that. But we can double check this by going forward a few frames. Let's say frame 11, and then going to our smoke object and checking on collision. There's the collision that's being calculated. If we go forward even more, we can start seeing that this will change with the plates. So let's say frame 32, and sure enough, we do have some of these pieces, going up like that. You might want to have a more refined voxel count if you want to really get the motion for these pieces. So we do lose a lot of detail, but I just want to show you that the process is generally working. And the combination of that with the collision velocity is going to provide the correct sort of collision for smoke.